Right, okay, so this little problem here. I've left town for the weekend and Martin is having a party. He's invited Victor the vole, Susie the squirrel, Fergus the ferret, Trevor the toad, and they decide to stand on the kitchen floor, so they form a regular hexagon. And you'll see I've done a regular hexagon already, and what you'll also notice is that I've divided it up into equilateral triangles because each interior angle is 120. Then if you divide it in half, you get 60 at every corner. So therefore, you can divide it up into equilateral triangles. Now, it doesn't matter where you start with the O, as long as you go round in order. So I'm going to put the O, the M, the V, the S, the F, and the T here. Now, this is his mouse hole O, and he has position vector M from his mouse hole. Okay. And we know that Victor has a position vector relative to O of V. Let's just put these in different color. So there's V. Go rub that out and put M there. So we got the vector M going from here to here, and the vector V going from here to here. And we want to put all the other vectors in terms of M and V. So what we've got to do is we're going to work out our way around this matrix using M and V. Now, there's a couple of ways to do it. You could try and work out what this one is before you start, and then be able to use that in the rest of the question. Or you can realize you can go V, then minus 2M, then V to get to S, and then you might realize the geometry and get to F that way. I think it might be easier if we just start off with working out what MV is here. So we're going to go from capital M to capital V, and we're going to do it by going from M to O to V. So that's equal to MO plus OV. Note this letter here is the same as this letter here when you're doing your chain around your vector framework. And to get from N to O, we've got to go in the opposite direction to M. So that's got to be equal to minus M. Okay, going that way, and then we're going to add on V. And we probably better write this as V minus M. So if we want to find OS, then we know we've got two of these to do. Two lots of MV. So OS equals two lots of MV. And two lots of MV is going to be equal to 2V minus 2M. Note I'm underlining all my vectors to indicate they are vectors and not scalars. Okay, a scalar being just a number, it doesn't have direction. A vector has direction. So next we're going to have a look at OT. So if we just do OT, what we can see is we can go up from here to here and then across to here. And this is just the same as MV. And then we're going to add on minus M here to get it. So OT will equal what MV is, which is V minus M. And then we're going to go in the opposite direction along here. So we're going along there, then along there, and we take another M off. So we get V minus 2M for OT. And then if we want to find OF, we can just do OT plus TF. I'm just going to scroll across a bit more to fit this in. So we're going to find OF will equal OT plus TF, which is equal to OT is V minus 2M. And we add on TF, and TF is the same as MV. So we're going to add on another V, and we're going to take off another M, V minus M. So that would equal 2V minus 3M. Now last, we've got Wally the Wasp joins the party and stands exactly halfway between Susie and Trevor. Let's just put that in green, shall we? There's Wally. And he's going to stand exactly halfway between Trevor and Susie. So we've just got a half OT plus a half TS. Now half TS is a half of OV. So we've got OT, so OW, there's W, will equal OT plus a half of what OV is. So OT we've already found is V minus 2M. And then we're going to add on to that our half OV. And OV we already found out is just V. So we're just going to add on to that a half V. So you get V plus a half V is 3 over 2V minus a 2M. And that's our answer to where Wally the Wasp is.